Today is the 26th. 126. And this will be the last of this. And so today we're talking about parallel. And watch out, big word coming up here. Because you guys are ninth graders and you haven't taken geometry yet, there's a pretty good chance that you don't know like full-on formal definitions of the second word. Almost everybody, there comes a point in like fifth or sixth grade where you just know what the first word means, right? And rarely when I teach this lesson does anyone get the words out that I'm looking for. Because in geometry, um, when your teacher says, what does it mean for two lines to be parallel? Your answer should robotically be this: two lines that lie in the same plane and never intersect. Just for the record, okay? But in algebra class, that's not what I want from you. So can you guys think about what it is that makes two lines parallel? And again, you can't say that they don't cross because I already brought that one up. What is it about lines that makes them never cross? How's that possible? Say that again. That's it right there. And so for two lines to be parallel, you have to simply know that they have the same slope. And that is a much more Algebra 1 relevant definition of parallel than two lines that lie in the same plane and never intersect. So for our purposes here, for the next few days or so, the word parallel to us means two lines that have the same slope. Okay. So that's, I mean, again, so when you head over to geometry next year across the hall, that other definition is going to be pretty awesome. Two lines that lie in the same plane and never intersect. That's a good geometry definition. But in algebra, since we talk about slopes and points and y-intercepts and stuff like that, our definition should be two lines that have the same slope. Okay. So let's take a look at what that means for us real quick. So if I were to give you a problem that said, I want you to write me the equation of a line that passes through the point -4, 11, and is parallel to the line y equals 1/2 of x minus 5. Having talked about what we just talked about, even though this is new, it shouldn't be something that we panic about because, again, what does it mean to be parallel? Same slope. And so some people get this really quick and some people will struggle with it for days, which it's just kind of human nature, right? But this line right here has a slope of up one, right two, right? So every line that's going to be parallel to it also has to go up one and right two. So what would be the slope of any line that's parallel to the one that I've got circled? Correct. So in reality, what I'm asking you to do in this problem is something you've done dozens of times. And that is, I want you to write me the equation of the line that passes through the point -4, 11, and has a slope of 1/2. You just have to put aside the newness and the potential confusion of this and say, wait a second, are you just asking me to take the slope from this line, steal it, and use it? And the answer is, yep, I am. The question inevitably that someone would ask is, well, what about the -5? And the answer is, I couldn't care less. The only way I could care less about that -5 would be if I were dead. It has absolutely no relevance in this problem. I simply want my line to be parallel to you. You have a slope of 1/2. Enough said. At this point, this information that I'm going to cross out in green no longer is necessary. I got what I came for, and now I'm going to do the problem like I've done dozens of times before. So my equation, as per usual, will say y minus 11 equals 1/2 of x plus 4, like that. You grab the slope you want, and then you run the other way and do your problem. Now, of course, based on where we are in this class, you know that that's not the final answer. That's merely our foot in the door. So from here, we have more work to do. What is the first thing we would do to fix this? Distribute. When you look at my answer key later on, you'll see that I'm pretty repetitive about the amount of steps that I show. So I'm going to take the half and I'm going to distribute it to the x and get a half of x. I'm going to keep this as a plus sign. And then I'm going to take 1/2 of 4. 1/2 times 4 means 1/2 of 4, which is 2. And then what's the final step? If I add 11 to both sides, then I'm done. I get y equals 1/2 of x plus 2 plus 2 plus 11 is plus 13. And this is the final answer. And you will note, of course, that sure enough, the line that I wrote has a slope of a half, and the line that I was told to be parallel to also has a slope of a half. Mission accomplished. Bless you. And again, that for some of you already is ridiculously, hilariously simple. And then there will be some who just say, I don't get this parallel thing. And it takes 5 minutes, 2 days. It's hard with some people just to get over that hurdle. But all I'm asking you to do is steal the slope and go do the problem. Now, the other word in the notes up at the top was perpendicular. Perpendicular. Okay. Does anyone know the definition of perpendicular? And this one is, I'll tell you the definition that your geometry teacher will want next year. Perpendicular lines are two lines that intersect and form a right angle. Okay. Sometimes people just say they're lines that cross. Those are just called intersecting lines. If they cross and they make a perfect right angle, like if you were to look up at the ceiling, those drop ceiling supports, those metal, the framework that goes across it, those are perpendicular lines because when they cross, they make 90 degrees. But that doesn't help us in this class. What do you think? What do you think, Jojo? So here's a line, and I'm just going to make up a slope. I'm just going to tell you that the slope of that line is 2/3. Okay. Now what I'm going to do is try to help you visualize what perpendicular means in algebra class. And so if I draw a line, like if I drew this, you would say, Mr. Ahern, that's clearly not making a right angle, right? But if I were to draw this, then I think I could make a pretty strong case that what I've done is made two lines that when they cross, right here, you can see they make 90 degrees, don't they? So use some common sense. If the white line is going 2/3 up 2, 3 to the right, what could you conjecture is the slope of the red line, Jojo? 2/3. It's not negative 2/3. Negative 2/3, by the way, excellent guess. Negative 2/3, it's hard for me. I can't really, I don't know if I can do this. Negative 2/3 would be about like that, right? You see that? Yeah. So if the first line has a slope of 2/3, the second slope isn't going to have the same ratio because it's got 2 verticals for every 3 horizontals. The other one has to be a different sort of setup. You want to try again? By the way, it is definitely negative. I agree. You have the brain power to figure this out, every one of you.
Equals huge.
So I do agree that it's negative because it's got to have a negative to be perpendicular to a positive, right? Common sense there. Thoughts? First off, can we all agree that the red line has to be steeper than the white line? I hope you agree with that statement.
Yes.
It has to be. To perpendicularize it, it's got to be. What do you think his ratio is? The white line goes up 2, 3 to the right.
-3.
There it is. Thank you, Rowdy. The red line definitively has a slope of -3/2. So what we can conjecture, theorize from this is, wait a second, let me get this straight. If you give me the slope of one line, but you want me to be perpendicular to it, I can make 2 changes to the slope. What are they? You change the sign and
2 thirds, positive 2 thirds.
you flip it over. Very good. There's a name for this in mathematics. We call it the opposite reciprocal. Just so that's how you come up with a perpendicular slope, is you change the sign. We call that an opposite, and then you reciprocate it. Call that a reciprocal when you take a fraction and you flip it over. Okay. So having said that, you might wonder, well, why is that important? Well, it's important because if I ask you, your next task is this. I want you to write me the equation of the line that passes through the point 5, -2 and is perpendicular to the line y equals 5x minus. Thinking again is the same. The thinking is, all I'm really wanting, it's like when you go to like a junkyard and you might just be looking for one headlight, right? And so there may be an entire car there, but you just want the headlight, or maybe you just want the door handle or something like that. So that's kind of where I'm at with this, is I'm only interested in one part of this line. What is it? Just his slope. What is his slope? His slope is 5. I don't want that slope, though. I don't want to use that slope because I'm not being told to be parallel to this line. I'm being told to be perpendicular to this line. That's what it is. Nice job, Jojo. And so again, if I can crack the code, I understand that, wait a second, are you just asking me to write the equation of the line that passes through the point 5, -2 and has a slope of -5 flip-flopped? Yes. I'm taking the slope that someone gives me and I'm changing the sign and flipping it over. And then all of this stuff that I'm about to cross out in green matters not beyond this point, because I'm right back to something that I've done dozens of times before. So you go in, grab the slope, run the other way. So my equation in its initial form is going to be y plus 2 equals -1/5 of x minus 5, like this. Parallel means steal the slope, use it. Perpendicular means steal the slope, modify it, use it. And so to finish this problem, I would just do y plus 2 equals -1/5 of x plus 1, because a fifth times 5 is 1. And then I would subtract that 2 from both sides and I'd be done. So I would get y equals -1/5 of x minus 1. Done. Yes, sir.
I'm kind of confused of the -1/5. Where you got slope.
The slope of this line is 5. We agree?
Mhm.
And so that's 5/1. That's what 5 means, right? And so to do the perpendicular of that, we always apply 2 treatments to any slope. We change the sign to negative and we flip it over. Okay. If it's negative, that's why I don't say we make it negative. We change the sign. So if it's already negative, then we change it to positive. Yes. Okay. There are 2 more new things in these notes, and then we'll do a little bit more review that's basically just rehashing the same concepts. So here's your next task. I want you to write me the equation of the line that passes through the point -6, 7. Did that just for you, Rowdy, just so you could look around and make sure that people notice that I said 6, 7. There you go, buddy. I was like, Rowdy will love this problem if I make it say 6 and 7. And we're going to be parallel to the line y equals 8. It's when I teach you guys, I'm here to talk to you and I'm here to ask you prompting questions. A good a good page of notes will be something that you can make that substitutes out for me. Since on quiz day, I won't be there to ask questions in order. You have to ask them yourself. So here goes question number 1. What kind of line is that? That is a horizontal line. And again, on when I'm sitting here, this will all click. You've got to find a little flowcharty way to put this in your notes so that you remember this on quiz day. So the line that I gave you is a horizontal line. What would be parallel to a horizontal line?
Yeah.
What would be parallel to a horizontal line?
Another one.
Another horizontal line. It's the only way to be parallel to horizontal is to also be horizontal, right? Bless you, Bella. We agree?
Mhm.
Therefore, I'm asking you to write me the equation of the purple line. And how do you write the equation of a horizontal line? Y equals a number. And which of these two numbers is the y coordinate? Done. Parallel to a horizontal is another horizontal. Done. Those are 3-second problems. You almost could not show work if you tried. Like it's not even really possible. You just have to understand what that is. Last one before I then start repeating myself, and then we go back through and review what we've learned. So this time I want you to go through the point 3, -4. And I'm going to start abbreviating the word perpendicular, PERP. So we're going to be perpendicular to the line y equals 3. I've always said that these are not math problems. These are logic problems. Some people try to make them into math problems, and they're the ones who go, I don't get this. Don't make a math problem out of this. What kind of line did I give you? A horizontal line. What is the only way to be perpendicular to a horizontal line? To be a vertical line.
X equals 3.
So I'm asking you to write the equation of the purple line. Vertical is the only way to be perpendicular to horizontal. And so you just say, oh, so you're asking me to write the equation of the purple line? I am. X equals, and then you simply pick the one of the two numbers in the point that's your X and say, done. Out. Should be the simplest problems ever you could find on a test. But history has proven that they tend not to be, which is weird. All right, let's repeat what we've just learned real quick. This should take about, I don't know, 10 minutes, and then I'll be done with you. So here we go. This time I want you to do this, and I'm going to help a little bit less this time. So I want you to do this on your own, and I'll give you a couple of minutes, and then I'll catch up to you. So we're going to go through the point 8, -2. Bless you. And we're going to be parallel, sorry, that little L, to the line y equals -2/3 of x plus 15. Go for it. I'm just going to get started with you to make sure that you're on the right track. You can't really have success in these, bless you, if you don't at least start off. So the logic goes like this. This line has a slope of -2/3. If I'm going to be parallel to him, then my slope also has to be -2/3. And then the problem begins, and you can dispose of all of this information over here. You got what you came for. You got that one car part. You may now pay for it and go on your way. So our equation is going to say y plus 2 equals -2/3 of x minus 8. So I hope you all got this far. And then you see what I meant when I said we're going to get one of those bad fractions, because when you do eventually this distribution right here, you're going to run into some issues because 8 can't be divided by 3. That's done. See a lot of people staring at me. I'll get caught up to you. So then you should have y plus 2 equals -2/3 of x plus. And what's this going to wind up being? Thanks. What is the answer?
16 thirds.
You're the man today. Yes, 16/3. Doing a great job. Right. And it does become a plus because it's a negative and a negative multiplying together. Any questions on 16/3? You cannot reduce 16/3. Okay. They cannot be divided by anything other than 1, of course. So at this point, I'm going to subtract 2 from both sides. When I subtract 2 on the right, what form am I going to subtract 2 in?
Sixes. Yeah.
6/3.
Six.
Right? So I want it still to equal the number 2, but I want it to have the bottom of 3. So I'm actually going to subtract 6/3 from this side. And that leads me to my answer, which is y equals negative 2/3 of x plus 10/3. Great job if you got that.
I have the same thing except for x minus 10 thirds. Because I get lost.
This is just a positive 16 minus 6. 16 minus 6 is plus 10, right? Of course. So, all right, let's go again. And again, I'll give you a couple minutes to be on your own with this. Let's go through the point negative 12, 5. And let's be perpendicular to the line y equals 3x minus 724.6, repeating. And why did I put 724.6?
Doesn't matter.
Because it doesn't matter, right? So I think that we're all to the point where we understand that. That number is completely irrelevant. So remember, you take the slope out of the line, steal it, right? But we don't want that slope. What slope do we want? The opposite and the reciprocal. You have to treat it twice. So number 1, I'm going to make my slope a negative since 3 is a positive, and I'm going to take that 3 over 1, and I'm going to flip it over to 1 over 3. So the slope that you would be using for the duration now of this problem is negative 1 over 3. And at that point, you can dispose of all of this. It's no longer relevant. Okay. Today's lesson doesn't have a lot of meat on the bone. It's just, I know from experience, it takes time to get us over that hurdle where we can read all the words and understand what it means. You're just playing with slopes. So my initial equation, yours should have said y minus 5 equals negative 1/3 of x plus 12. Is this a friendly fraction or an evil fraction?
Evil.
Definitely friendly because 12 can be divided by 3. Those two numbers I just circled, if they can divide by each other, then this is going to be a non-issue for us. So I'm going to copy down the y minus 5. And of course, I'm going to do this easy one, equals negative 1/3 of x. And because it's a negative hitting a positive, I'm going to go ahead and just put my minus right now. And to do the yellow arrow, you have to just know, some of you just know 1/3 of 12 is 4. Some of you might be more comfortable writing it over here as 1/3 times 12 over 1. Whatever floats your boat. You could reduce now or later. 1 times 12 is 12. 3 times 1 is 3. 12/3 reduces to 4. And you see, that's just an auto-eliminating fraction. Love those. If you add 5 to both sides, you're done. Y equals negative 1/3 of x. Negative 4 plus 5 is positive, so plus 1. Done. Okay. Parallel, steal the slope, keep it the same. Perpendicular, steal the slope, but give it the old switch flip. Switch flip. Oop, double ding it. Oop. 2 more. And these are short ones. They should be. So for our 7th example, we're going to go through the point 13, negative 41. And we're going to be parallel to the line x equals negative 1. Again, this problem should take less than, including writing time, less than 2.5 seconds. What kind of line did I give you? correct. If I'm giving you a vertical line and I'm asking you to give me one back that's parallel to him, am I not just asking you to give me another vertical line? Right? So I just write x equals, and which number do I pick? Done. And then for our very last one, and then I'll shut up, we're going to go through the point, -9, 8, and we're going to be perpendicular to the line x equals 4. I will say again that this is not a math problem. 0% math. Logic. What kind of line did I give you?
A vertical.
A vertical. What is the only way to be perpendicular to vertical?
Y equals A.
What is the only way to be perpendicular to vertical? Correct. So the logic is I need the purple line. And the purple line has to be horizontal, which is y equals. You pick the y, and you're done. I'm going to hand out assignment 36. You're going to spend the rest of your day working on 35 and or 36. We will be quizzing this week for sure. So just kind of have that in your mind. Got it? All right. So we're going through the point -2, -3. And we're going to be perpendicular to the line y equals 5x plus 3. So can you guys all tell me, what does it mean again in this class to be perpendicular? What is it? Why do I care?
Opposite.
Nice job. Way to say that. Opposite reciprocal. So what I'm going to do is I'm going to go to the line that I'm given, and I'm going to steal his slope, 5. But then, since it's a perpendicular problem, I'm going to do 2 modifications to that 5. 5/1, right? So that's what we know 5 is. I'm going to modify it by first taking it from a positive to a negative. And then I'm going to flip the 5 and the 1 to become a 1 and a 5. So for the next minute or so, for this problem, that will be our slope. Are we good on that? Okay. So again, all of this stuff over here now does not need to exist anymore. I got what I came for. And so now I'm going to write my equation, which is y plus 3 equals -1/5 times x plus 2. And then you can see that this fraction isn't going to be a nice one because the 2 and the 5 aren't going to divide, right? And so when well, first let's get the easy part done first. We have the y plus 3, and then we have the easy -1/5 of x. But then the trouble is the yellow arrow. And that's, again, I know that that's always going to be a conversation. So it's going to be a point of conversation. So do you know what it equals? It's okay. I'm just going to write it down. I'm going to write 1/5 times 2. And eventually, they'll promise you won't need to do this once you just start seeing the shortcutty things. I don't want to force the shortcut, though. I want you just to when you're ready. But do you agree that that's what 1/5 times 2 looks like, right? The purple thing? Nothing reduces, so I just go 1 times 2 is 2. 5 times 1 is 5. It's just 2/5. It is what it is, right? So I'm just going to put minus 2/5. And I know it's minus because there's a negative times a positive, right? Be okay to hear? And then this, again, I know will be a hot spot for issues, is that I have to know. It's not the algebra that's hard. That's what I find about it. It's usually not algebra that's difficult, it's arithmetic. And so if I subtract 3 from this side, which of course I have to do, when I subtract 3 on this side, I don't want to subtract it as 3 or 3/1 or 6/2 or 9/3. What do I want it to be? What version of the number 3 do I want? You can write 3 a ton of different ways, right? Which one do we want? Right, because it equals 3, but it has the right bottom. So when I subtract, I'm actually subtracting 15/5.
It's number 2.
It is. And so I wind up with my answer. I'm done. I get y equals -1/5 of x. And here's what I know for sure, that whatever I put over here is going to have 5 for its bottom. So I could at least get that much of it done. But as I said to Rowdy earlier, all you got to know now is just to take the top numbers. What's -2 minus 15? So I put negative 17 and I'm done. That's it. So number 3 says we're going to go through this point and we're going to be parallel to this line. And as long as I understand what parallel is all about, I understand that it just means to have the same slope. And so I take this line's slope and I steal it. And what do I do with it? I copy it. I don't change it at all because parallel means keep it the same. Keep it, don't change a thing. And so this problem really is just saying write the equation of the line that passes through the point 5, -4 and has a slope of -6/5. And all of this over here is now irrelevant. So what will my equation initially say? Like, what's my foot in the door equation, Rowdy?
4 plus 4 -6 for this x plus or -5.
Excellent work, man. And you can see why this fraction isn't going to cause me any stress because this number that I'm circling in purple can divide evenly by the number that I'm circling in green. And whenever that's true, then you know you're not going to have any fractions when you're done. It's nice. So I'm going to copy down the easy parts. So I have y plus 4 equals -6/5 of x. But then comes the stressful part, the yellow arrow. And some of you already know the answer is 6, and some of you don't. And so the way for all of us to come to that agreement is if you're not sure how to do it quickly, then go off to the side and write it down. Here's 6/5 times 5. Half of people would cross the 5s out early. Other half would say, I don't want to. They would just go 6 times 5 is 30. 5 times 1 is 5. What's 30 divided by 5? So I just put a 6 here. Then the only question remaining is, should I put a plus or a minus? And the answer is, well, of course, put a plus because it's a negative times a negative. And then what's the last step? Absolutely. And this isn't one where I need to worry about all that, make the bottoms the same thing, because they're just whole numbers, man. So if I subtract 4, just regular old innocent 4, I'm done. I get y equals -6/5 of x plus 6 minus 4 is 2. Done. Parallel, steal the slope, keep it the same. Perpendicular, steal the slope, flip it over, make it opposited.